Hello everyone, welcome to the sixth video in this series. We start with problem number 51. A bridge rectifier is preferred over an ordinary full rectifier because its transformer does not require a center trap. Only a normal transformer is required. Center trap transformers are more costly. So option B is the correct answer. Problem number 52. In penning gauge, the pressure P is related to the discharge current I via the relation I equals to K P to the power N, where N varies from 1 to 1.4. So I see the value in option C is given from 1.1 to 1.2. So this should be the correct answer. Problem number 53. Which of the following is an absolute gauge? Absolute gauge is the pressure measured with respect to the vacuum. So option A, Knudsen gauge, is the correct answer. Problem number 54. Which of the following functions may be fitted with experimental data using the technique of linear least square fit? A polynomial can be fitted. So option C is the correct answer. Problem 55. The wave function of a state of the one-dimensional harmonic oscillator with angular frequency omega is given by psi equal to psi naught plus 2 psi 1, where psi naught and psi 1 are the ground state and the first excited state respectively. What is the expectation value of the energy? So let us first normalize this state. So we calculate psi, the inner product of psi is equal to 1 plus 4, that is 5. So the normalized wave function psi is given by 1 by square root of phi psi naught plus 2 psi 1. Now the expectation value can be calculated as Ci squared, since these are real, times Ei. We know the energy eigenvalues for the harmonic oscillator is I plus half h bar omega. So let us calculate that. So this is C0 squared E0 plus C1 squared E1, and C0 squared is 1 by 5 and the E naught is equal to half h bar omega, and C1 squared is 4 by 5 and E1 is 3 by 2 h bar omega. So you calculate this thing, this would be 1 plus 12 divided by 10 h bar omega, that is 13 by 10 h bar omega. So option A is the correct answer. Problem 56. In estimating a physical quantity I, which is given by this, one measures the variable m, p, x and d. In a given observation, relative errors in these quantities are this and this respectively. What will be the maximum proportional error in the measurement of I? To find the maximal proportional error, we take log on both sides of this equation. Thus log of I is equal to log of m minus log of p plus 4 log of x plus 3 by 2 log d. Now we take the derivative. So delta I by I is equal to delta m by m minus delta p by p plus 4 times delta x by x plus 3 by 2 times delta d by d. Now when you calculate the relative error, that is delta I by I, you have to add all the relative errors. So essentially you can add a plus sign here. So delta m by m is given as this, so we just put those values. 0.01 plus delta p by p is 0.03 plus delta x 4 times delta x by x is 0.025 times 4 plus 3 by 2 times 0.02, and that is 0.04 plus 0.1 plus 0.03, that is 0.17 or 17%. So option A is the correct answer. Problem number 57. A mineral consists of a cubic close packed structure formed by oxide ions where half of the octahedral voids are occupied by aluminium ion and 1/8 of the tetrahedral voids are occupied by manganese ion. The chemical formula for the mineral is, so let us calculate the number of each of the ions. So the number of oxide ions 4 and the number of aluminium ions is 1/2 of the number of octahedral voids, that is 4 equal to 2, and the number of manganese ion is 1/8 of the number of tetrahedral voids, that is 8 is equal to 1. So the formula is MnAl2O4. Option B is the correct answer. Problem number 58. A solid contains n spin-half magnetic atoms. At sufficiently high temperatures, the atoms are randomly oriented, while at sufficiently low temperatures, they are perfectly aligned. The heat capacity is given by this. Determine the maximum value of C0. So the entropy S is defined as Kb log of the number of microstates. In our case, the number of microstate is 2 to the power n for n particles. So this is equal to n Kb ln2. On the other hand, we can calculate entropy using the following formula. So let us now calculate this integral. So we have S is equal to T0 integral over T0 to 3 T0 C0 and 1 by T0 minus 1 by T dt, and this is equal to T by T0 minus log of T, and we have to calculate from T0 to 3 T0. This is equal to C0 2 minus log 3. Thus we have C0 is equal to n Kb log 2 divided by 2 minus log 3. Option A is the correct answer. Problem 59. A system uses a 12-bit word to represent the input signal. If the maximum peak-to-peak voltage at the output is set for 4 volt, then the typical value for the step size will be. So the resolution of the analog to digital converter is defined as R is equal to V peak to peak divided by 2 to the power n, where n is the number of bits. In this case, we have V peak to peak is 4 volt divided by 2 to the power 12. So let us convert this into microvolt. This is equal to 4 into 10 to the power 6 divided by 2 to the power 12 microvolt. So if you calculate this quantity, this would be 976 microvolt. So option B is the correct answer. Problem 60. The short wavelength cutoff of the continuous X-ray spectrum from a nickel target is this nanometer. The voltage required to be applied on the X-ray tube is what? So remember that when the energetic electrons hit the nickel target, X-rays are produced. So when the wavelength of the X-ray is minimum, those are the X-rays with maximum energy. That happens when the entire kinetic energy of the electron is transferred to the X-ray energy. So in that case, the electron energy is equal to E times V. V is the voltage difference between the X-ray tube, is equal to Hc by lambda. That's the energy of the X-ray. So we find V is equal to Hc by lambda E. Put the values of H, C and electron charge, and lambda is this, and you will find the voltage to be around 15 kilovolt. So option C is the correct answer.